All right, guys, we are moving into the second video for section 1.2. And so if you missed out on the first part, then definitely go back and watch that. But this is our second video on that section. We had just done domain and range. Now we're going to move into different ways to analyze functions. Now this is not it. We are going to cover more things as well, but I figured as far as a bunch of things at one time, here you go. When you analyze functions, again, we're able to look at functions and be able to determine features about them, even if you don't know every single little thing. All right, so we can know if a function is considered positive if wherever the outputs y are going to be greater than 0. So basically, wherever you see it above the x-axis. You can see where a function is negative when you see the outputs for y that are less than 0, so where it is showing below the x-axis. You can see where it is increasing on the intervals. Wherever you see the x's are going up, the y's also go up. And it will decrease if, as the x's go up, the y's go down. Okay, so like as you're reading a book from left to right, if the function is going up, it's increasing. If it is going down, it is decreasing. Okay, and there will be intervals where it can do both. A function is constant if it has no change. As you look at it from left to right, does it stay flat? Does it go up or down at all? If it doesn't, that's constant. Okay, we have this idea of concave up if it bends up, if it curves up like a U shape, or it can be concave down if it bends down like a rainbow. And then we have points of inflection, because points of concavity can change, and that point of inflection talks about where the point is when it changes concavity. Okay. So if it changes between being concave up or concave down, that point where it changes, that's your point of inflection. So we've got a bit of an interesting problem here. It's a little bit, I don't have an equation to go with this, definitely. This is like a bunch of different equations that are kind of all pieced together, okay? And what they're gonna ask us to do is be able to determine where the function is positive or negative, where is it increasing, decreasing, or constant? Where is it concave up or down? And are there any points of inflection where it switches from going from being concave up to being concave down, or vice versa? All right, so we're going to go through this. If you need to pause and take notes, then feel free. But I'm going to switch this over to my page where I'm going to write on it. Okay, so right here, I've kind of already got this set up. Set up a place where we're going to put our positivity, our negativity, increasing, decreasing, constant, concave up, concave down, and our inflection point. And you might be saying, like, what if it's not, like, it's not just positive or negative. There are places, there are intervals where it is positive, there are intervals where it is negative. There are intervals where it increases, there are intervals where it decreases. And they want us to give the x values. That's what our intervals are going to be notating, is our x values where those are happening. Okay? So when we talk about positive, I'm looking at the intervals for where this thing is above the x-axis. Well, it is above the x-axis right here, but then it hits the x-axis again. Okay, so we're going to give these little intervals, but keep in mind that this is going to be, it's not above the axis at 3. Okay, but after 3 it is. So we're putting the little parentheses here to say it not where the graph equals 3, but that is the point where it begins to go above. And so it's from 3 until 1, 2, 3, 4, 5, and then it hits the x-axis again, so it is no longer positive. But then it jumps right back up. So from 5 all the way to 6, 7, 8, 9, when it goes back down, then it drops below. And then here at 10, it hits the x-axis again, and then it's showing that it's going to go up forever. So we're going to say here at 10 to infinity, it's also positive. Okay, notice on the left-hand side, it did not have an arrow showing that it was going up. It was like that was a starting point. Okay. All right, negative. We're looking at where it is below the x-axis. Well, that is here from -1 to +3. -1 to +3. But it is also over here from 9 to 10. So it's negative in all those places because it is below the x-axis. All right, let's look at places where it is increasing. So what I want you to think of is as you're drawing this, what is your hand doing if you draw it from left to right? Well, if I start at this point and I start to trace it, my hand is going down. That means it is decreasing. But it hits this point and it starts to increase again, right? So when we're talking about points where it is increasing, it starts increasing right here where your x value is 1. So it is increasing from 1 and it continues to increase. My hand keeps going up, 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 up until I get here where x is 1, 2, 3, 4. Then it decreases, but once my x reaches 1, 2, 3, 4, 5, it starts to increase again. So from 5 to 6, it increases. Then it remains constant. It begins to decrease, and it does not begin to go back up until right here at about 9.5, all the way to infinity. Look at your decreasing. Again, that's where I'm looking at this and saying, when is my hand going down? Well, when I start here at -1, it already starts off by decreasing until I get to where your x is 1. And once I get where x is 1, it increases until we got to that point, 1, 2, 3, 4. Here at where x is 4, it begins to decrease again, okay? So where it goes from 4 to 5, it decreases. Then it increases, stays constant, decreases. So here, this is at 1, 2, 3, 4, 5, 6, 7, 8. And it decreases from 8 until about 9.5 before it starts going back up again. All right, constant, that one's pretty simple. There's only one section where it remains constant, and that's right here where it's flattened off. That is between 1, 2, 3, 4, 5, 6, 7, 8. So 6 to 8, that's going to be constant. Concave up, we're looking at where is this thing kind of in that U shape. So I'm looking here, that is definitely concave up from -1 to +3. Then it switches and it's concave down. Okay, right there I'm seeing an inflection point where that concavity switched. That was here at the point 3, 0. All right, again, I'm looking at my concave up. Well, it was concave up from -1 to 3. Then this was not really concave up. It didn't curve. This is a sharp uptick. That is a line. That is not a curve. So that's not concave. Okay? Then it is constant. Again, that's not concave. But then here, I see this was intended to be like a straight line from here, then a straight line to here. Okay? Not technically supposed to be a curve, but my curve begins again down here where my x is 9.5 all the way to infinity. If I was a computer, that would be a little bit better at being clear. Concave down is where it is like a rainbow shape. So you're looking at here between x's 3 and 5. And that's really the only place where it is like that U shape, okay? Oh, sorry, that rainbow shape. That's really it. The only inflection point I had where it switched from concave up to concave down or vice versa, it was only here at this one little location, 3, 0. Everything else was not technically a point of inflection. So I know that's a little bit weird, but that is something that they will ask a lot about um, in this course. You're going to see a lot of that kind of talk. So very important that we see a detailed explanation like that one, okay? All right, so the next topic we're going to talk about here is talking about your rate of change, which you guys will have learned quite a bit about in your Algebra 1 and Algebra 2. We think of that as your slope or rise over run. But as we go forward in this class, rate of change is not just simply going to be that. In some situations, we will be looking at your rate of change may be increasing or decreasing as you look at a shape. Okay, so I want to point some things out. This, again, they said here we're looking at tangent lines. And if you guys can recall from your previous math classes, particularly geometry, tangent is talking about a line that just barely grazes a figure. So I'm going to show you something. This is concave up, okay? Now we're going to look here at a couple different points. Okay, so if I were to draw a tangent line, okay, I'm going to put this one here in this kind of purpley color. Let's say that it hits right there. Yes, that is a negative tangent line, but I want you to then look at a point just a little bit further along the figure, maybe right here. And I want you to compare the two tangent lines. They are both negative, okay? But one of them has a little bit of a higher value than the other. The first one was pretty steep going down. The second one, not as steep, meaning that it's actually a higher value. Okay, it's less negative because it's less steep in that negative direction. Well, let's see if I look at another one a little bit further along the way. That's even less steep and a larger number. If you look at the next one, okay, look at another place along here. Look at these tangent values. Okay, now it's starting to become positive, but bigger picture, it's getting more and more, it's getting higher and higher. That's what I'm looking at. It goes from being straight like this, a little bit less steep, going negative, which means it's a higher number, a little bit higher, a little bit higher, a little bit higher, a little bit higher, a little bit higher. And what we're seeing is that all of those rates of change are increasing as you go along that figure. And that is really what we want to see when we're talking about things being concave up. Concave down is actually the exact opposite. If you're looking at the rates of change as you look along your figure, okay, you start off with a fairly high rate of change for that tangent line, okay? But as you go along that figure, look at what happens. That rate of change is actually, that slope is actually less. It's still positive, but it is less. All right, well, look a little bit further along, right? That's even less. And so for concave down, we're seeing this rate of change, this average rate of change begins to decrease. It's not that it's always negative, because sometimes it's not. Sometimes it's positive, just like on this side. But it's decreasing as it goes along the figure. That's how we want to talk about concave down. Not just saying that it's curved one way or the other, but we want to talk about what is that rate of change doing. Okay, so that's just a little note on concavity for those of y'all taking the AP course. That is what they really want to see, not just say which way is it curved. So if you're explaining why a function is concave up or down, we need to use that wording. The rate of change is increasing or the rate of change is decreasing. Okay, next thing we're going to talk about, boundedness. Okay, a function can be bounded below or bounded above, okay, just depending on this scenario. So bounded below, if there's a number b such that b is less than or equal to f of x for every x. Function can be bounded above if the b is greater, if there's a b greater than or equal to x for every single x. Or we can just say it's bounded if it is bounded both above and below. We can even say that something is bounded on an interval. Okay, now I know that may sound a little bit like nonsense, but let's look at a problem together and see if we can make some sense of what that wording means. Okay, so we're going to look at those two problems that you see on your screen. We're going to we're going to do this by graphing and seeing what happens with this. Okay, so what I would do is I would suggest throwing these into a graphing calculator and see what that shows you. Okay. You can even pause the video and do that. The next thing I'm going to show you is what those graphs look like once you graph them. Okay. All right. This guy's going to look a bit like a parabola because it is a parabola. It's going to look like a parabola. Now, there is a section where it comes below the x-axis, so I want to make sure we're seeing that. Okay. And that point where it hits, where it is that turning point, that lowest point here, this is the point 0, -4. So what I want us to see here is the fact that this really was bounded because it wasn't like the graph exists everywhere. Okay, this thing is bounded below. It cannot go below this certain point, -4. So we're going to say that this is bounded below at -4. But this next graph is a little bit weirder. Okay, so I'm going to graph this and let's see what it looks like. But it's not going to be really pretty. It's like comes down here, goes up, comes back down. Okay, and it kind of goes in that direction on either side. It's kind of weird. Okay, so what we're looking at here is this situation where it does not continue going up forever or down forever. This is bounded, and it is between these maximum minimum points here. Okay, it is not going to go up forever. It's not going to go down for forever. It's actually kind of getting closer and closer to the x-axis forever instead of going up or down for forever. So this is also considered bounded. It's not just considered bounded above or below. It's considered bounded because it is bounded both above and below. Okay? So that's really, I'm not going to ask a ton of stuff about boundedness, but you do want to try to understand that concept of what that means. It is not going to go above or below this point. Okay? Which brings us to my next favorite topic. And guys, this is such a huge one. We are going to spend some time with this type of thing, but extrema, minimum and maximums. You may have recognized this as like a vertex from a parabola. You would have a minimum or a maximum, but all kinds of polynomial functions, they will have multiple extrema. Okay, so we have relative extremas, which are the local. We have absolute, which is global. That means like the greatest maximum or the lowest minimum if there are multiple. Okay, and we have one more example that I have for this video. We're going to talk about number 7. That's my example, number 7. Okay, right here, where it says find the local extrema for that function. They give me here f of x equals x to the 4th minus 7x squared plus 6x if they exist, and give the values of x and y. So, y'all, this is the situation where there are going to be some times where you're going to be able to do this fine by hand. However, most of the time, that's not the case. Most of the time, it's going to be really ugly to try to do it by hand. So I'm going to encourage you guys to get to use your calculator on this one, okay? So for a problem like this, I would go into your calculator and I would start plugging in these different things. We have x to the 4th minus 7 and x to the 2nd plus 6x. Okay, and I would say look at your graph. Now, there will be some times where you look at this and you think you might have the minimum or the maximum or whatever. Our calculator is really cool with the fact that it allows you to easily find things. If you go to this little calculate section right there, and it says find. Look at this, guys. Maximum, minimum. I can make it find those for me. So my maximum here is at the point where my x, here, I'm going to sketch this real quick on my paper. One sec, sorry. Okay. So I'm going to sketch this real quick on here just so that we can kind of see it and I can write on it. So we have down here, there's a turning, there's a, like that, kind of, sort of. Okay. So this point would be considered a maximum. We also have two minimums, those little turning points. So this maximum, we're seeing that my x is 0.455. We're going to round that 556. Actually, we only want three decimal places. That's something that we want to get in the habit of. So really, it should be 0.456. Okay? And there, my y is at 1.324-ish if we round it. Okay? So this is a maximum. But I can also make it go back and calculate. So I'm going to go back. And I'm going to make it find my minimums for me because there are more than one. So we're going to go to minimum. And you'll see this first one, right? So the minimum here, this guy right there, he was at the point negative 2.05. That's going to round up to 7. So x would have been negative 2.057. And my y equals negative 24.057. That's one minimum. My other minimum right in here, all I have to do is make my cursor go to the right, and it should find that other one and pop those values down here. Okay, so this other minimum, my x, this is another minimum, I'm going to label that. We have x equals 1.601, and my y is negative 1.766. All right, so you can see we have one maximum and two minimums. You can give the x and y values. You can write it as a coordinate, all that jazz. All right, guys, that is it for this video. That was minimum and maximums. Definitely stay tuned so that you can end up seeing the rest of section 1.2. The next video will be the last one. So see you in the next one. Bye.